Very good morning, my dear student. So today I'll going to discuss about the introduction to computer system. Under the introduction to computer system, today's topic that I'll going to discuss is about the different structures of a computer and its some input and output unit. So those the structures of computer and its input and output unit, what we will going to discuss today. We can see here that at first of all I have taken out 2 points. First point is the input unit. Input unit means what? The device through which data and program from the outside of the world will enter inside the computer system. Okay, so outside of the world it will going to enter inside the computer system. So this is what the input section is. And output unit, what do you mean by output unit? A device through which the results stored in the computer memory, okay, and are able for the outsider to see the particular thing what is been done. That means the result what is there stored in computer can be visible to the outside people. That means what we are saying, that one section is there where we are having some input. Okay, so we are having some input. That means suppose if this is the thing, then there we are getting the input from where? From this particular area. Okay, and we are having the output. As it process, it gives some output that we all know. That means this particular area it will going to give this particular output. So we have those pattern of input unit and output unit, with the help of which we can find it that we can give the data and we can work with the data. That means we can make the outer world to visualize the fact what is there or stored in the computer system or in the computer memory. So there are the different type of pattern of work that we can find are being stored in the computer memory. Okay, so when we are talking about the computer, what we find it that in a computer it comprises of the three basic section. Clear? So it comprises of the three basic section. What is those three basic section? That you all know. One is the arithmetic and logic unit. Okay, another is a control unit, another is a memory unit. Now arithmetic and logic unit, that means what we can find it that arithmetic operations, different pattern of arithmetic operations like the additions, like the subtractions, okay, the program logics operations, and or not, all these things what are there that will going to work on this particular area. Okay, so as this is going to work on this particular area, we can find it the small amount of a special storage called a register. Okay, so modern arithmetic logic unit have a small amount of a special storage that is called a register, that can be used to access faster than the main memory. Okay, so as it find it that we are having this particular pattern of data storage and data structure. So all this data storage and data structure, what is there we find that the device can do the work, and device can find out that where and how we can perform this particular work. Okay, so and operation, or operation, not operation. So all these different pattern of operations what are there, so all these different pattern of operations can be done with the help of arithmetic and logic unit. That means these are the logical operations, and or not, all these are the logical operations. So those the logical operations can be done as well as addition, subtractions, isn't it? So all this particular thing also can be done with the help of this particular what different types of operations that are available. Clear? So we have a very small section or special storage unit that is called a register. So inside the register what we can do, we can find the data what are there, all the data are stored in this particular area. Okay, so data are stored in this particular area. That means it can do the work faster and it can make our work accessible. Number one. Number two is a control unit. What is this particular control unit is? Now a control unit, we say that it is organized, okay, the computer to work in a computer as a single unit and generations. Okay, so this is the control signal from the various devices regarding to read, write or to execute the operations. Clear? So regarding to the read, write and executing of the operations, we can find it that this is the one section which will going to work on it. Okay, so as we find it that this particular section is working, we see it that each of this particular section have a different type of units, and those the different pattern of units, they are going to work on this particular scenario or this particular structure. Okay, so this is the thing what we can find, this is the thing what we can see, that all this particular work, all this particular section of the work will be there in this particular control unit. Next what we find it, a memory. Memory means what? A collection of a cell, each of this unique physical feature. That means we have a different pattern of physical feature of the memory sections. That memory is consisted of a different types of byte addresses. Okay, like here you can see the cell address is given, so which contain this particular value. So this is the value 10101010. So as you find this particular value is there, those the value what we will going to have, we find it that each of these particular values will going to make an effect on it. Okay, so this is the thing, this is the particular part what we find, that there are the different type of cell we do have, and cell do contains the different addresses. Okay, so unique address is there. Based on this unique address, what we find it that we can comprise and we can make the memory. Clear? So as we can make the memory, we can find out that which of this particular section will going to work on it and which of the particular section will going to have the ability to do the access of the particular work. Okay, so accessibility of the work, that we find it that will going to work on this particular memory sections. Okay, so this is how we can see that how we can find those the different sections are there and how those different sections will be executing their work. Now as we are talking about it, we find it that there is a central processing unit, CPU. You all know about it, that this is an electronic circuit, and after this electronic circuit what it does, it will carry the actual processing system, and using that actual processing system we refers to the brain of a computer. Okay, so this particular section is said as a brain of a computer. What we find it, that commonly we can find it the processing will be done, and after the processing will be done, then we can find that each of this section there is one or more microchips is there. So that is an integrated circuit, IC. So those the ICs what are there, ICs are having a semiconductor material. Okay, so ICs are having the semiconductor material. That means what we find, the CPU having sorry, CPU is giving the instruction and data through which the program will going to execute. Okay, so the CPU sorry, fetch the program from the different sections. Okay, so as CPU fetch the program from the different section, we find it those the arithmetical operations what are there and the logical operations what are there as per the given instructions, and storage of this particular thing, the result will be in the memory section. Okay, so those the thing what we find it that it will going to execute. Fine. So when we are having those particular pattern of devices, when we are having those particular pattern of memory that we are working with, so while we find it, the processing is been done. While we find it, this particular processing, we do have a storage there. Okay, different pattern of storages are there. So as well as the instruction, the logical memory is called an register. Okay, so while processing, the CPU stored the data and instruction where it will going to store to the logical memory, which we call as a register. Clear? So this particular register will going to give the take the input and work with an input. So registers are what? Are the part of CPU chips. Clear? And they are in limited size and numbers. Okay, so different registers are used to store the data. They are used for storing of the data, the instructions. Okay, all those data and instructions what are there, we find it that is an intermediate results are being produced. Clear? So different pattern of intermediate results are been produced. Producing those intermediate result, we find it those the data and instructions what are there, they will going to do the work and they will going to serve the particular work very proper way. So what we find it that when we are having the register, when we are having the two components like arithmetic logic unit, the control unit, we find it that all these things performs the arithmetic and logical operations that is needed to done for what? Done for the different purpose of the particular processing system. As the instructions what we are giving, we find it that control unit requires the sequence. Okay, different sequential instructions for execution purpose. Clear? So interprets the instructions and the guidance of the data flow that is been done in the computer memory. So arithmetic logic unit and input unit or output devices, what we find that those the different output devices, input unit we are having on it, we are finding that each of this particular section, each of this particular data what are there, so those the data will going to do the access of it and it will going to make the output from there. Okay, that means our total structure or our total work that is being executed, that the data, how the data will flow, from where the data will come, how it will going to execute. So every part will be taken care of by what? With the control unit. Okay. So this is the thing what we can see, this is the thing we can find it that we do have an arithmetic logic unit, we have a control unit, and based on this particular arithmetic logic unit and control unit, we can work on this particular area. Okay, we can work on this particular area. So now little bit I will discuss about the input devices. We do have a different pattern of the input devices. So when we find that we are working on those input devices, so each of these particular input devices what are there, each of these particular input devices what you are sending and you are terming them, we find it that we can convert the data and we can move with this particular sections. So there are different type of input devices are there. You can see here like keyboard, very common, mouse, this is also very common, scanner is there, touch phone or touch screen is there. So different type of input devices are there. Okay, so all these different pattern of input devices, what they use to do the acceptance of the data from the outer world. Okay, so especially what we find that braille keyboards was been used by the person who are visually impairments. Okay, so there we find it that this is the thing what we are doing, they are taking the input. Now nowadays we have a voice, we are finding the voice are being executed, voice are being made, and we can send the voice also. So those the data what is there, those the data part what is there, we are sending each and every data part from one particular area to the another area. Okay, so these the things, this the particular structure that we build. The data enter into the input devices in a temporary storage in the main memory. Main memory means the RAM. Okay, so as it's stored temporarily in the RAM, what we find it, there are the permanent storage area is there. So in this storage area, there is a temporary storage area as well as there is also a permanent storage area. So in this particular permanent storage area, we find it that we can give the instruction, we can store the data and we can work with the data. That means there is an additional storage sections, the locations based on which where we will going to send the data and how we can work with the data. Clear? So this is the part, this is the thing we can see that we do have an input unit and we are finding those particular thing through the input unit. What we are doing, we are sending the structure, we are working with the structure. Okay, so those are the different pattern of input devices are there as we are working with those input devices. Now you see another thing that is known as an output device. Okay, so output device, very common thing, like the monitor is there, you can see here the display monitor is there, the speaker is there, the scanner is there, 3D printer is there, so many things are there. So those the output device what we find from the computer system that will going to display on what, display on the product, on the output device that are converted the digital information into the human understandable information. Okay, human understandable form, that means how the human can understand and how the human can do the work on it. So we can send a different type of data and information. Clear? So those the data and information what we find it that they are needed to be interpreted in such a way so that the people can understand the particular thing. The people can work on that particular thing. So each of this particular working area, where we find that there are the different type of devices like the inkjet printer, okay, laser printer, dot matrix printer. So those the different pattern of printer what we find that each and every printer nowadays what we have a new data type of printing. Okay, so 3D printer is there which is used for the physical, okay, replica of the 3D design. 3D design means three-dimensional designing. Okay, so in this three-dimensional designing what we find it that printer will going to take the copy of the particular work and prototypes of this particular product is being used and that can be explored. Okay, so this is what we can find in medical field, in the different type of the development field. We can find it that we have a different body and different organizations of the work like body organs. For taking the picture of body organs, a 3D printer is being used so that the thing can be clearly understandable, it can be easily explainable. Okay, so this is the thing what we find, this is the part what we find that we have a different type of an output devices are there. So all those output devices what we have, all those output devices what we find that each and every output devices they has their special utility or special working power. There are the what, some are in the form of an hard copy, some are in the form of a soft copy. Okay, now like I am printing it out, I am making a 3D printing, that means I am making a hard copy of it. If I am seeing it in the monitor, if I am seeing in my screen, that is the soft copy I am using. Okay, so those the thing what we can find, those the part what we can find that we use all this thing and we make all this thing to be explored by the different people in the different area. Okay, so different people in the different area that will going to make the work very much effective, very much what, catchy to the different patterns of people or different types of people. So see here I'll explain one thing that is very important, that is a von Neumann architecture of computer. Now von Neumann architecture of computer means what? You can find here there is a central processing unit. Okay, in this particular central processing unit, what we have the memory, we have the storage of the data, program input, okay, and output is there. So all these different pattern of devices what we are making to communicate, there are the different channels are there through which what we find data will transmit. So electronic numerical integrator and computer ENIC is the first binary programming language based on von Neumann architecture. So during the year of 1970, we find it there is a large scale integrations, okay, in the electronic circuits allowed to integrate what the complete CPU in a single chip, isn't it? So there is a different pattern of a microprocessor. Okay, so Moore's law, there is a Moore's law. Gordon Moore's introduced the Moore's law, which predict that the number of transistors on a chip would be doubled every 2 years, while the cost would have half. So that means the working capability will going to increase as well as cost will be reduced. So this is what the Moore's law. Based on this Moore's law, we find it different type of integrations of the 3 million components of the different computers are there. They are being utilized in a large scale integration phase. So this is what we can see, this is what we can find, that there is a feasible and fabricated high destinations of the work, and when we find this high destination of the work, we can find it that approx 160 component of a single IC is called a super large scale integration. Clear? So those the super large scale integration is been introduced. So we find it that this particular introduction of the devices which we are introducing in this manner in the work of the area, we find it they are being used, like in the PC personal computer in the year of 1981, we find that Apple has introduced that Macintosh. Okay, so this is how we can find how the thing is been working, and we can find how the thing will going to do the different work. So see here, in the different generation from 1940 it has started, we find it that how the thing has gone to 2020, up to 2020 the chart has been given to you. You can see here that from the different area, invention of the transistor in this between of 1940 to 1950, and it has increased double in 2 years. Okay, 4040, then 8086, so it is doubling, then Pentium 4, I-core, Duo 2, all these thing came. Okay, so this is the thing what we find, the integrated circuit, that means one integration circuit, now it has become, say how many integration circuits are being used there. So this is what the different time we can find different types of ICs are increasing, but what we find it, the cost is been reducing. Okay, so that is the major thing what we know, that means working power should increase, but the cost is reduced to decrease. So those are the machines what we find, that each and every machines are being used for the graphical user phase and operating system of the Microsoft. Okay, in this particular thing, Unix and DOS, those are the languages we find. In 1990 we find there is a growth of World Wide Web, WWW is there. Okay, so further accelerated to the mass, and we can use them for the different particular purpose, like laptop we are using at this moment. We see the personal computer is been done. Okay, so portable of this particular computer, we find the smartphone, we find the tablets are there. So those are the things what we see, those are the things what we find, that will going to assign about the digital computer system. Okay, so on this digital computer system we have a different pattern of technology. So each and every technology what we introduce, we find that we need to do the work in a very high speed. So very high speed means in this particular scenario we find it the structure will going to do the work, the computer will going to make the devices, those the devices what with different gadgets. Okay, the smart watches, the lenses, all these things, the handbags, okay, headphone, etc, etc, so many things we can find. So each and everything what is there what we are using, we are using ultimately the thing that is an artificial intelligence. Okay, so as we are using the artificial intelligence, obviously we can find that how this artificial intelligence nowadays working in the different area on the different arena. So this is how we are making the change in the world of your computer system. So today I am ending my session here. Thank you all.